Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 243. Please turn to it, page number 243, and today is our lesson number 346. These problems that you see there, the algebra exercises on page number 243, are the same problems that appeared in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solution, you will find the original solution on day number 136. So here we go. These are algebra exercises. It's important that you have the book in front of you so that you can follow my work, because sometimes my handwriting turns out to be quite atrocious and it's difficult to read. Having the book in front of you will help you. Problem number 1, it says, problem number 1a, that is, it says square of y, the square of y is subtracted from 5. What does that tell us? The square of y is subtracted from 5, so that is 5 minus y squared. It's not y squared minus 5. This would be 5 is subtracted from the square of y. The second part would be 5 is subtracted from the square of y. That's not what we're dealing with here. It says square of y is subtracted from 5. So we have 5 is subtracted the square of y, and the result is multiplied by 37. And the result is multiplied by 37. So we have that, and we just multiply. This implies that we have, let's erase all of this thing, we don't need this. And that implies that we take our result, 5 minus y squared, and we just multiply by 37. That's it. You can leave it like this, or you can open the parentheses and simplify it. That's all there is. Second one, 3 times x is squared. 3 times x is squared. 3 times x is squared, and the result is divided by 7. And the result is divided by 7. So we take our result, 3 times x is squared, and divided by 7. Again, if you want to open it up, simplify it a little bit more. 3 times 3 is 9, so we get 9 squared, 9x squared over 7. Last one, product of x plus 4 and y, product of x plus 4 and y is added to 18, So that implies that we have 18 plus x plus y times y. Again, we can leave it like this, or we can simplify it. Let's simplify this thing a little bit. So we get x times y, we get y times 4 plus 18. That's all. That's all there is. 18 plus x times y plus 4y. Let's go to problem number 2. That was it. These are very simple, very straightforward one. By the way, if there is anything here that gives you trouble, if there is anything here that gives you even slightest bit of trouble, that's a clear indication that you need help in algebra, that you need to improve your algebraic skill. At my channel you will find 200 videos that will teach you. If you are interested in teaching yourself algebra, make sure you go through them one by one in the proper sequence. The first 100 videos you will find on dealing with algebra, they deal with the basic concepts of algebra, and then you will find 100 more algebra problems, which are algebra word problems. If you are interested in improving your algebraic skill, if you happen to be weak in algebra. Anyway, number 2. Problem number 2. I'm going to change the markers. This one is too light. And problem number 2 simply asks us to simplify things. Simplify the following expression. It says simplify the following algebraic expressions. Let's see what the first one we have. 3x squared minus 6 plus x plus 11 minus x squared plus 5x. These are the kind of things that I'm talking about. If you, as I said already before, if you need help in algebra, the help is there. You just have to avail yourself to it. So here we have 3x squared, which is a positive sign. Here we have negative 1x squared. These are called adding the like terms. Adding the like terms. Like as in similar. As opposed to unlike terms. Unlike terms are terms that are dissimilar. These are similar terms because they have the same exponent, x squared. Positive 3 and a negative 1 is going to give us positive 2x squared. Then we look for x's. Here we have 1x and here we have 5x. 1x plus 5x is going to give us 6x. And then we look for the constant. Here we have negative 6 and a positive 11. Negative 6 and a positive 11 is going to give us positive 5. That's it, we're done. 2x squared plus 6x plus 5. Number 2. That's it, we're done with this one. Three times 5x minus 1 minus x plus 4. Let's see what we can do here. The first thing we have to do is open the parentheses. Open the parentheses. 3 times 5 is going to give us 15x. 3 times negative 1 is going to give us negative 3, negative x, and a 4. So here we have positive 15x, here we have negative 1x, positive 15x, and a negative 1x. 15 minus 1 is 14, so we get 14x. And then we have a negative 3 and a positive 4 is going to give us positive 1. Quite straightforward, quite simple. Number 3. Let's see what number 3 says. Number three is a little tricky one. Let's keep part C in abeyance right now. Let's keep it aside. We'll deal with it in a second. Let's go to D. X plus 5 times 3x minus 1. 2x plus 5 times 3x minus 1. So we multiply here. 2x times 3x is going to give us 2x times 3x. This is 2x times negative 1 is going to give us negative 2x. Positive 5 times 3x is going to give us positive 15x. And then 5 times negative 1 is going to give us negative 5. And how much does this work out to be? 3x, well 2x times 3x is going to give us 6x squared. The first term works out to be 6x squared. And now we just have to add the like terms. We have negative 2 and a positive 15. A negative 2 and a positive 15 is going to give us positive 13. So we get 6x squared plus 13x minus 5. That's all. 6x squared plus 13x minus 5. Let's do C. Let's do part C. When did we learn about abeyance? Abeyance, as I just said, it just means to put something aside, as in we'll deal with it later. I know we learned about abeyance, we have done it many times, we have come across this word many a times. Now, day number 9. In our vocabulary lessons, in day 9 we learned about abeyance. If you're interested in improving your vocabulary, just look for this particular video, just type in GRE vocabulary words or simply vocabulary words, day 9, and you will see it. Now problem number C. Part C deals with something that we have to talk about separately. There are three formulas that we must know for the exams, and I'm going to list all three of those formulas, even though here we only need one of those three formulas, but for the exam it is good to know all three of them. The first one is a plus b whole squared. A plus b whole squared is simply a plus b times a plus b. Now if it turns out that during the exam you can't remember what does a plus b whole squared equals to, this is by the way read as, this is read as a plus, this is read as a plus b whole squared. This is a plus b whole squared means you take the whole thing and you square it. This is a plus b squared. This is different. A plus b squared means exactly what it says, a plus b squared. You have to say a plus b whole squared so that we can put the whole quantity in the square. So it is a plus b whole squared. Next one is a minus b whole squared. And the last one is what is known as a squared minus b squared. And this formula is what is known as difference of two squares. Difference of two squares. Let's do all of them one by one, shall we? So the first one was a plus b whole squared, which is a plus b times a plus b. So that's going to give us a squared, and then a times b is going to give us ab, and then b times a is going to give us another ab, and then b times b is going to give us b squared. And that boils down to, we have ab and an ab, it boils down to a squared plus 2ab plus b squared. I know you know this thing. It does not hurt to refresh our memory in case you have not seen it in a while. The next one is a minus b whole squared, which is a minus b times a minus b. Again, if you forget during the exam what it is exactly, it only takes 10 seconds to actually do it out. Just like here, a times a is going to be a squared, a times a negative b, because it has negative here, it's going to be negative ab, negative b times a positive a is going to give you another negative ab, and then negative b times negative b. Negative b times negative b is going to give us positive b squared, which is negative b times a negative b. And when we simplify it, we get a squared here, and then negative ab and a negative ab is going to give us negative 2ab plus b squared. So far so good. Let's do the last one. The last one deals with, so here we have a plus b times a plus b. Okay, listen what happens here. Here we have a plus b times a plus b, then we have a minus b times a minus b, and the last one that we have to deal with for the exam is a plus b times a minus b. We have to remember what the product of these three quantities equal to, these three pairs. So here we have a times a, which is a squared, and then a times negative b is going to give us negative ab, and here positive b times a positive a is going to give us positive ab, because this is positive and this is positive, and a positive b and a negative b is going to give us negative b squared, which is the product of positive b and a negative b. What do we notice here? What we notice here is that we have a negative ab here and we have a positive ab here. They drop out. They drop out, and what we end up is a squared minus b squared. A squared minus b squared, and this is called the difference of two squares. We must know all of these three formulas, and in the exam you're going to need one of these three formulas in a question such as part C. In part C, let's take a look at part C in a second. In part C, so for the part C we don't need first or second formula, we need the third one. But of course you have to know all three of them, because it depends on the question. You have to know all three of them for the exam. In part C, we have, on the top we have x squared minus 16. Okay, listen carefully. X squared minus 16, which is same as x squared minus 4 squared. So here our x is a and our b is 4. And same exact thing is going to apply. And finally what it boils down to, this is essentially x squared minus 4 squared, which is a plus b. Our a is x, so it's going to be x plus 4 times x minus 4. That's what we have on the top. And on the bottom we have x minus 4. On the bottom we have x minus 4. And if you are able to see this thing right away, it is a very simple, very straightforward problem. So we have, on the top we have x squared minus 4 squared, we have x squared minus 16, x squared minus 16 is same as x squared minus 4 squared, and on the bottom we have x minus 4. X squared minus 4 squared is same as x plus 4 times x minus 4. A plus b times a minus b. X minus 4 and x minus 4 is going to cancel out from the top and the bottom, and we are left with x plus 4. That's all. That's all there is. What I want to do right now, actually, I'm going to give you a little homework. And we'll do this problem tomorrow in the next video. And here's your homework. I'm going to put it down here. Let's put the homework separately by itself. It's a quantitative comparison question. Quantitative comparison question, and this is how it looks like. We are told that x plus 7 equals 7. Sorry, we are told x plus b, a plus b rather. We are told that a plus b equals 7. We are also told that a squared plus b squared equals 40. This is the part we are told between the two columns. They give you information that appears between the two columns that applies obviously to the entire problem. And here are two columns, column A and column B. And what we are asked to compare is the product of A times B, AB, versus 5. I want you to work on this problem yourself. Do not watch the next video, tomorrow's video, day number 347. Do not watch that video until you have worked on this yourself. Okay? You'll get more out of it that way if you try it yourself first, the problem, before you watch the solution, before you do the work together. Okay? I'll see you tomorrow. Bye now.